All right, today we are diving into one of the biggest, most mind-bending mysteries in all of science. We're talking about a number so spectacularly wrong that it's been called the greatest blunder in the history of physics. Think of this as a cosmic detective story, and the clues are literally woven into the fabric of space and time.
So, what is this colossal mistake we're talking about? You've got to understand this isn't just a simple rounding error. Oh no. This is a deep, fundamental disagreement between our absolute best theories of the universe and what we actually go out and measure. And the scale of this error is, well, it's almost impossible to wrap your head around.
Okay, so to get to the bottom of this, we have to start at what you might call the scene of the crime, the universe itself. For decades now, astronomers have been meticulously gathering evidence, and what they've found points to a really shocking truth about the ultimate fate of, well, everything.
See, what they found is that the expansion of the universe isn't slowing down like you'd expect, from gravity pulling everything back together. Nope, it's actually speeding up. Galaxies are flying away from each other faster and faster every second. Physicists have given a name to whatever's causing this. They call it dark energy, or sometimes the cosmological constant, which they write with the Greek letter lambda. It's kind of like this gentle, constant push that's embedded in space-time itself. And this, right here, is where our mystery really begins. Because when we actually look out at the cosmos, we measure a tiny, incredibly gentle amount of this dark energy. But when we ask our most powerful, most trusted theories in physics to predict how much energy there should be, they tell us that empty space should be seething, absolutely boiling, with a colossal amount of energy. The two stories just don't add up, not even close. So where on earth does this completely wild prediction come from? Well, it's time to meet our prime suspect. And the crazy thing is, it's the single most successful, most precise, and most rigorously tested theory in the entire history of science. Let me introduce you to quantum field theory, or QFT for short. This isn't some fringe idea. This is the absolute bedrock of modern physics. It's the theory that makes your phone work, that makes lasers possible. It describes the subatomic world with mind-boggling precision. And for decades, it's had a perfect track record. It has never, not once, made a prediction that an experiment later proved wrong. Or so we thought. And look, QFT's strange ideas about empty space aren't just a mathematical fantasy. We have real experimental proof that this so-called vacuum energy exists. You've got things like the Casimir effect, where two perfectly neutral metal plates in a vacuum actually get pushed together by this energy. Then there's the Lamb shift, a tiny change in an atom's energy levels caused by these exact same quantum jitters. These experiments prove that this vacuum energy is very, very real.
So let's recap. We have our star witness, QFT, with a flawless record. We know its claims about vacuum energy are based in reality because we can measure its effects. So naturally, we ask it a simple question.
All right, QFT, you're on the stand. Just tell us the number. How much of this dark energy, this vacuum energy, should there be pushing our universe apart? And the answer it gives is an absolute catastrophe. The number that quantum field theory predicts is bigger than the number we actually observe by a factor of 1 followed by 120 zeros. I can't even say that number. Let that sink in for a second. That's not a little bit wrong. It's not even a lot wrong. It is by far the most wrong prediction in the entire history of science. It's no surprise it's been called the single greatest disagreement between theory and experiment in all of science. I mean, think about it like this. If your theory predicted the length of a football field was longer than the entire observable universe, you would still be closer to the right answer than QFT is, right here. It's that bad. An epic failure like this deserves an epic name, and it's got one: the Vacuum Catastrophe. What this really is a head-on collision. It's a clash of titans between our theory of the very small, quantum mechanics, and our theory of the very large, cosmology. And they are not playing nice. So, what do you do? What do you do when your star witness gives testimony that's this unbelievable? Well, you have to start looking for other explanations. You have to start investigating other suspects. And that's exactly what physicists have been doing for decades. And they've come up with some pretty fascinating ideas. So here's the new lineup. Could the answer be something called supersymmetry? This beautiful idea that every particle has a hidden partner that magically cancels out most of its energy? Or what about the anthropic principle? This one's a bit wild. Maybe there are countless universes out there, a multiverse, and we just happen to live in the one where the energy was low enough for stars and galaxies and, well, us to form. Other ideas suggest dark energy isn't constant at all, but a changing field they call quintessence. And of course, some people are pointing the finger at the other theory in the room, suggesting maybe our theory of gravity is what's actually broken.
But here's the bottom line. For all these clever, really intriguing ideas, we have zero proof, not a shred of conclusive evidence for any of them. The case file is still wide open, and the mystery just keeps getting deeper. And let's be really clear about what's at stake here. This isn't just about finding the right number to plug into an equation. This is a crack running right through the foundations of modern physics. It's telling us, loud and clear, that our two greatest descriptions of reality, quantum field theory and general relativity, are fundamentally incompatible. It means there's a huge piece of the cosmic puzzle that we are completely, utterly missing. But a crisis like this is also an opportunity. It could be forcing us toward a massive revolution in our understanding. It might mean that QFT, for all its glory, just breaks down at these huge cosmic scales. It could even mean that our entire idea of space-time as this fundamental background is wrong, that it's just an emergent property of something much deeper. What this problem is screaming at us is that we need a brand new idea, a new principle of physics that we haven't even dreamed up yet. And so we end right here, with the question that literally keeps physicists up at night. The vacuum catastrophe isn't just a number. It's a message sent to us from the universe, telling us that we are profoundly misunderstanding something about the nature of reality itself. And whoever finally solves this mystery won't just be fixing an equation. They will be changing everything we think we know.